Okay, I realized I hadn't made a key for this part, so I'll just go ahead and make a video key just for part 3 of this recitation. So I'm going to start with drawing the structure of each of these. So isopropyl it looks sort of like a Y, but it has 3 carbons like that. And then this would be your parent chain. I'm going to draw like a squiggly line. This carbon is your point of attachment to the parent chain. So hopefully that makes sense. So it's that carbon right there is not part of the isopropyl. It is an attachment to the, sorry, that went out of focus so bad. It's an attachment to the parent chain. And then for isobutyl, so if we still have our same parent chain, there's an attachment. It looks the same. It has the Y, just the same, but it has a little bend in it. So isopropyl has 3 carbons. All of the butyl groups have 4 carbons. So isobutyl has 4 carbons. And then sec-butyl, we have a butyl group, and it's attached right here where there's 2 carbons on either side, so it's secondary. So that's why we call this sec-butyl. And remember, the sec does not get included in nomenclature. It doesn't get included in the alphabetical order of the nomenclature. Okay, the other 4 carbon we have is tert-butyl. So if we had our little parent chain, that's what tert-butyl looks like. So 1, 2, 3, 4 carbons. And again, we don't count the tert-butyl. And then for 5 carbons, or we don't have to count the tert in the alphabetical, we just count the B. And then for 5 carbons, we have neopentyl, which looks like this. So it looks just like the tert-butyl, but it has a bend in it. So sort of like how isopropyl and isobutyl are just slightly different. That's how neopentyl and tert-butyl are. Okay, and then if I was going to give these the IUPAC names, you start numbering from the parent chain. So 1, 2. So this would be an ethyl. And notice I write ethyl and not ethane because this is a substituent. So the parent chain within the substituent is ethyl. And then we have a methyl group at carbon 1. So that's 1-methyl ethyl. Then for isobutyl, we start numbering from the nearest point to the parent chain. So 1, 2, 3. So we would call this 2-methyl, 1, 2, 3, propyl. Okay, and then sec-butyl, 1, 2, 3 is the longest carbon chain. We number 1, 2, 3. So that's propyl again, and then 1-methyl propyl. And then for tert-butyl, we have 1, 2, so ethyl. But we would have 2, 2, I ran out of room. 2, 2 dash dimethyl because there's 2 methyl groups on carbon 2. And you can number 1, 2, 1, 2. It doesn't matter. All of them, you'll end up with ethyl. So 2, 2 dimethyl. 2, 2 dimethyl ethyl. And then for neopentyl, we have, here's our point of attachment. So 1, 2, 3. So we have 2, 2 dimethyl because there's 2 methyls on carbon 2. And then propyl. So you need to be able to go from, sorry, I'm just moving stuff out of the way on my desk. You need to be able to go from the common name to the IUPAC name for each of these, because you need to know how to name substituents in general. So you need to know the IUPAC name for these substituents, but you can also know the tert-butyl, isopropyl common names. Okay, and then the last one was to put the substituent on the second carbon of a propane and then give the IUPAC name to the whole molecule. So this would be isopropyl. That was the isopropyl, but on the propane, now it becomes 1, 2, 3, 4. So 1, 2, 3, 4. So that's butane. And then we have a methyl on 2 and 3. So 2-methyl, 3-methyl. So combine that all and we get 2, 3 dimethyl butane would be the whole name. Okay, again, we have our propane. And then with our propane, we would put isobutyl on there. So that's the Y. So that is what the substituent would look like. But now we have to number it, and there could be a longer chain. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think 5 is the longest chain. 1, 2, 3, 4, 5. It's the longest chain I can find. So I'm going to go with that. 1, 2, 3, 4, 5. I think that's the longest chain. We had 1, 2, 3, 4, 5. That would be 2 different. Okay. So either way, our substituents, yeah, I think that would be right. And then we have 2 and 4 for our 2 and 4 dimethyl. They're each a methyl group. So we would name this 2, 4 dash dimethyl propane. Okay, and then now we have propane here. And we're going to add sec-butyl to it. So the point of attachment is like this, 1, 2, 3, 4. So that's our sec-butyl. So now we name it. Let's find a parent chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I think no matter how we count it, it's going to end up with 5. So that's pentane. And then we have, let's see, methyl right here and methyl right here. So 2, 3 dimethyl pentane. So there shouldn't be a space between that, but that would be how I would name that. Okay, and the next one is tert-butyl. So it would look like this. So 1, 2, 3, 4, I believe is the longest chain I can find. I can't really find anything longer. So that's butane. And then we have 1, 2, 3. Okay, so we have 3 methyls. So we'll use trimethyl. We still have to say what number it would be. So it'd be 2, 3, 3. But if we named it the other way, let me get a different color here. So if we started here, 1, 2, 3, 4, then it would be 2, 2, 3 trimethyl. So that way, I think gives us the lowest overall numbers. So I think we would go with that. So 2, 2, 3 trimethyl butane. Okay, and then the last one, I'll start moving up here, is neopentyl. So that looks like this. 1, 2, 3, 4, 5. Yep. Okay. So let's find our parent chain. 1, 2, 3, 4, 5. Looks like the longest one we'll find, I think. So that's pentane. And then we could number it either way. 1, 2, 3, 4, 5. Okay, so I see 2, 3 methyls. So again, that's trimethyl. And if we do it at the blue numbering scheme, it'd be 2, 2, 4. If we did it the other way, it would be 2, 4, 4. So 2, 2, 4 is better. So then I'll combine it all and do 2, 2, 4 trimethyl pentane. I ran out of space, but that's 2, 2, 4 dash trimethyl pentane is how I would name that. Okay, so I hope that was helpful. Let me know if you have any questions about that. Yeah.